Hello YouTube, RJ. Okay, so in this video, what I hope to do is I hope to make 4 different inductors. Probably can see I've got 4 different inductors, torads I should say, for inductors out here. Starting out with a FT5043, a T50-6, a T50-7, and a T68-6. And I'm going to make 4 torad inductors. And the purpose of this is we're going to test and see what the temperature stability of these different cores are and how they relate. The reason for the FT50-43, because it's a 43 type, okay. The T56 is the -6 is a very common one used in radio work. The -7 is, I guess, a newer type that some people claim are more stable temperature changes, and we're going to give that a try. And then another thing is commonly people say that going to a larger core helps with stability too. So by making these 4, we ought to be able to see correspondence between them, and so that's what we're going to do. And what I've done is I'll pop up here and show you. I went to this site and used the calculator. I use it all the time to figure out, exactly how many windings and such. And what I decided to do is just do 10 turns on each one of them, and that's going to give us quite a difference in inductance on the Type 43. As you can see, 44 microhenry is what the calculator says with 10 turns. We'll see how that comes out. But the others, 10 turns gets us pretty close. 0.4 microhenry, 0.43 microhenry, and 0.47 microhenry on the 68. So I also figured out how many inches of wire I need, and based on this, I'm going to do the winding now. I thought I'd show you how I do winding. Different people do it different ways. I didn't know if it would be something that would interest everyone, but I have this little clamp-on vise that I use, and what I do is I put this thing on the edge of my bench like this, and that's where the paintbrush comes in. Got just a cheap paintbrush, kind you can pick up pretty well anywhere. Michael's, any of the craft places or whatever. And I use this to do my winding. And so the first thing we've got to do is we've got to cut some wire. So we've got some enamel wire here for doing this. And what we're going to do is we need about 10 inches, it says, roughly. So let's go ahead and cut us a 10-inch piece, roughly. Maybe give myself just a little extra just to be safe. And let's start with the FT50-43. So we'll get us a torad out. Basically what I do is just drop this on here and use this as a holder. And then what I do is I just start by putting the wire through. Give me enough to work with easy. Pull it, wrap it, bring it over, bring it up a little bit so I can get the wire in again. Just enough, and that way the wire can't go overlap the previous turn. So bring it down just a little. We're going to take it and pull her down. Just got to remember, each time you go through the middle of that core, that's a turn. Now, I'm using fairly heavy wire here, so it's a little harder to get it to pull through good and tight, but you want to pull it nice and tight. And I like to push it down on the paintbrush, and that makes sure it pushes tight up in the torad, and you can actually pull up tight and flat the best we can, okay? And then you just keep doing that, and you just keep going through and spacing it somewhat even, keeping in mind how many turns you're going to put on this. In this case, 10, so it's going to not be that tightly wrapped to each other. You're going to have some spacing between the cores. So I just keep doing this, and I'm using a awful large wire for this. I wanted stability so the uh, wire could be wound, you know, pretty steadily on there, wouldn't change a lot, and that way we wouldn't have variations from that it would pretty well stay where I put it. So it's going to take me a little while to wind all these, and I'm probably winding it with too heavy a gauge wire here. I probably ought to be using something smaller. Um, but give me a little time, I'll get it made up, and then when we come back, I'll have it all completed. And what we'll do is we'll start a test on it before I wind the next one, and we'll put it in the LCR. Paintbrush gum loose. Put it in the LCR meter. See what we come out with on the inductance, what it actually turned out to be, and then we'll get it ready to put in the thermal test cell to test how much it varies. So I'll be back. Okay, with that I've got the toroid inductor created. I'm just going to let me go ahead and get this out of my way. Okay, so let's clip this off, and we need to clean the enamel off of there. So we'll get our, however you pronounce it, Nipix or whatever out, and we'll strip the enamel right off of there. Love these things, makes my life so much easier when it's time to do this. The wire, I doubt you can see that very well, but it cleans them perfectly. So let's pull out the inductance meter. I'll go ahead and calibrate it while I'm at it, and I'll fast forward through this because it takes just a little bit. Okay, and we're calibrated. We're ready to check our inductor here. Let's clip her up and see what we come up with. 50.8, 50.9. We're a little higher than what the calculator came out. I thought it was going to be 44 microhenries, and we're coming out 50.8 microhenries. So you have to take those. It all has to do with your winding, and you could squeeze these a little and change a little. I don't think you could change it that much though. But so there's our first one. So I've got 3 more of these to make, and what I'm going to do is I'm going to go ahead and set up the test cell. And what we're going to do is I'm going to put this in, and we're going to run a test on this as our first one. I'll do the other 3. I'll test them. It's going to take a little time because each test is going to be probably an hour. So it's going to be tomorrow sometime probably before I'm completely done. But we'll come back in the magic of editing. You'll come back in just a moment, and we'll have some data from these we'll be able to take a look at and see. Okay, we're back on the computer. We've completed the testing of our inductors with the different toroid cores. And here's the chart I've created from the data. Some somewhat interesting information, data. Pretty much follows what
we kind of expected from what we've been told, but with a few surprises. Now, obviously, the FT5043 core was, we knew that would not likely be one that would be very stable. And as you can see, here's our temperature. We start out just over 25 degrees C, and we wait 2 minutes. We start heating. Temperature climbs, levels out here 20 degrees C later. And the green line here, you can see the FT50.43, and you can see that, man, does it vary. What you've got here is your temperature on this side and your percentage of induction that changed. So whatever the change was, this is how many percent it changed. And as you can see here, that particular core changed well over almost 7.5%. So that would be quite a frequency change in most circuits. So, not a good candidate. We can see that clearly. And then we've got the rest of them down here with a few interesting outcomes. Now, what I did is, because this is kind of an outlier and compresses our data here, I made another chart where I dropped it out, and we'll jump to it in a second. But note that while this FT50-43, first of all, was a lot more inductance, as you would expect. But the change was, if you look down here, for the most part, about almost 7.5 times worse than using the iron powder cores. So let's jump over to our other chart. Okay, here this lets us throw the outlier out and kind of spread them apart a little and look at them a little bit better. First of all, let's talk about the T50-6. So the T50-6 is this orangish color right here. And we can see that it varied too, but notice our scale is now kind of compressed. Here's our 0% change, and this is 1%. So it varied just about 1%, just a tad under 1%. Big difference. And of course, we expected that to do better. But one of the odd things I did is you read a lot about people bowling their torad inductors to stabilize them. This same core got bowled after this, allowed to, return to room temperature, dry, and we ran it again. That's the black. Notice that it's a little less stable. It kind of, where T50-6 not bowled is pretty even. This kind of takes a little, jog here and there, and seems to be a little worse, which was surprising. Everybody seems to think that helps. I'm not sure why in my case we're not seeing that at all, but everything else was exactly the same. The test was run exactly the same in the chamber. It just didn't fare quite as well. It wasn't a big change, as you can see, but there was a change. Now, one of the other things that we wanted to look at was, commonly, you will read or hear or see on YouTube that going to a bigger core, if you have the space, can help. Well, I tried that by using a T68-6, and I would say that's somewhat true. You can see here it's a little bit worse than half what the smaller core. So there was definitely something to be gained here by going to a larger core. But the real shocker is, you'll hear people say, well, the 7 material they've got out, it's supposed to be a little bit better. In my testing, it's dramatically better, as you can see here. One thing to note is it tends to go down in inductance instead of up. All these went up, where the T50-7 went down in inductance. But look at how much it went down. Basically, you're looking at 0.25% here. So you're looking at about 4 times more stable over 20 degrees C than the 6 material. That I didn't expect. That shocked me. That tells me one thing: I need to be using -7 material in my VFO TORADs for sure. Um, and the other thing that this testing tells me is I might want to look at trying to go to a larger -7. I don't have any, so I couldn't test that yet. I might order some in and run that and include it in the test and see how it works out. But if I get the benefit of going up in core size that I have here with this T50-7, this will be a very temperature stable core for your inductors, and I think that will probably be my pick and what I'll go with. So I might, like I said, I might order some T68s in -7, run it on a test and give it a try, and compare it to these and see if you know if we can get from 1/4% over 20 degrees C, if we could get say half of that, get it down to 12, 0.12%, that would be phenomenal. So anyway, I hope you found this interesting and something to think about. This wasn't I put it in there, it worked, so I think that's great. This is we've run it over a temperature range in a controlled environment. This is what we see, so pretty happy with the outcome here. Pretty shocked to see just how much stability the -7 seems to gain you. Very interested in seeing how much going up in the core size gives you. So expect probably a short follow-up video on this video at some point where I try the T68 size -7 and we see how we do on that one. So hopefully this helps you decide what cores you want to use and what you're developing. So thank you for tuning in. Hope you find this show entertaining and educational, and I hope I'm doing something that you'd like to continue to see. And if so, please subscribe and like this video. Hope to see you again.